Hello and welcome. Today we will get ourselves introduced to a function that requires an operating system on our board. The function that we have chosen is the Ethernet connection. Yes, you can use your RA board to connect to the internet. The EK board comes with an RJ45 Ethernet connector which makes full use of the internet capabilities of the RA6 M4. From the user's manual, we can see the pins on the microcontroller that this Ethernet port is connected to. Usually, when we initialize a project, the Ethernet connector and its pins are already configured. Let's begin by creating a new project. We shall name this project Ethernet Demo. Then, we proceed to selecting the board, which is the EK RA6 M4 board for our case. In the RTOS selection page, we shall select the FreeRTOS option. This will enable the project to be built with the FreeRTOS on board. The FreeRTOS also has a minimal and blinky configuration. For our project, we can go with the minimal option. When the project has been generated, we can see that the FreeRTOS port stack has been included already. We then need to start organizing the libraries for the Ethernet connection. We shall make a new thread first. From the networking menu, we shall choose the FreeRTOS+TCP stack. This stack comes packaged with the Ethernet port, physical layer, and buffer allocation modules. We notice that the buffer allocation module is highlighted in red. Hovering over the I button, we learn that a heap implementation is required for this module. So, we navigate to a new stack and from the storage option, we choose heap 4. Now the heap stack is highlighted in red. In a similar way, we can see that the dynamic memory allocation support must be enabled for this stack. From the thread properties, we set the heap size to 8K and enable support for dynamic memory allocation. This will take out the error from the heap stack. Then we shall proceed to configure the properties of the TCP stack. For our configuration, the IP address will be configured as static and not obtained from the DHCP server on the network. So, we will need to disable the Use DHCP option, followed by disabling the 4 DHCP associated options. These are the only configuration change we need to make. We can then generate the project contents and start programming. First, we are going to include the FreeRTOS IP.h library. Then, we need to add the network configurations. Starting with the IP address for the board, which we choose ourselves, we give the number 118 for it. We then go and declare the subnet mask, the gateway address, the DNS server address, and a MAC address for our board. We can get the subnet mask and gateway address from the IP configurations in the terminal. We will enter the numbers in the form of an array. Then, we will create a Boolean variable for the network status flag and set the value to false. We also need to define the callback function application IP network event hook, which receives the network status and is used to set the status variable in our program. The data types for this function are defined in the FreeRTOS IP header file. Now we can proceed to the thread entry function. The API return status variable is of custom type called base type, defined in the port macro header file. We can then call the first API for the Ethernet connection, which is for initialization. We shall pass the IP address, subnet mask, gateway address, server address, and MAC address to this initialization function. We shall create a breakpoint for unsuccessful API calls and create a while loop to keep the program running while the array board remains online. Our basic internet connectivity has been programmed. All this is sufficient to take the board online. We can then build and debug the program. Before we run the program on our array board, we can check the contents of the address resolution protocol cache by typing ARP-A in the terminal. This will show the MAC address of all the active devices currently in the local network. We can see that our board is not currently listed. Now we continue running our program, which will take the array board online. The board must be connected to the local network via the Ethernet port. An Ethernet cable is usually supplied with the standard array board package. Now, when we check the ARP cache again, we can see that some device is online at IP address 118 and the MAC address is the same as what we have set for our board. We can also ping the device and see the packets being sent back. So that concludes the simple configuration of the array board for internet connectivity. See you in the next video.